Hi everyone, this is Mr. Campagna. Today we're going to be discussing how protons and neutrons contribute to nuclear stability. So our goal for today is that we will be able to explain how protons and neutrons can contribute to nuclear stability. We're going to be looking at a rather complex looking graph, and we're going to answer a few questions based on it. In a previous lesson, we talked about how subatomic particles can have states of stable and unstable equilibrium. One of the examples that you were given was that of a penny, and you could see how that in certain positions it was stable and in other positions it wasn't. I'd like you to pause the video now and answer the following question. What is the difference between stable and unstable equilibrium? Now, before we go any further, you must absolutely watch the video linked here. So pause the video, watch it, and we'll continue. Have you ever looked at a graph or figure and felt overwhelmed by it? Often there is a lot of information on graphs and figures. The identify and interpret strategy helps you make sense of graphs, figures, sketches, and other ways to represent data. The strategy helps you break down information into smaller parts. To do this, you will first identify what you see in the graph or figure. Then you will interpret each of those observations by deciding what they mean. Then finally, you will draw a conclusion based on the available data. So let's see if we can't interpret this chart. Now, step one for this strategy is to identify, and you're going to write down what I see comments. Identify any changes, trends, or differences you see in the graph or figure. Then draw arrows and write a what I see comment for each arrow. Be concise in your comments. These should be just what you can observe. Do not try to explain the meaning at this point. So to get started, let's try to identify the X and Y axes. Well, at the bottom of the chart, I see N, number of neutrons. So I'm going to assume that N equals the number of neutrons. Now, taking a look at the y-axis, I could see here that Z, it says number of protons, so I'm going to assume Z equals number of protons. So here's another what I see comment. Z equals N. So you can see here that they have labeled the line where the number of protons equal the number of neutrons. The plotted points seem to fall below the line Z equals N. All right, that brings us to step two, interpret. So what it means comments. Interpret the meaning of each what I see comment by writing a what it means comment. Do not try to interpret the whole graph or figure. So let's start off at the top. So for the what I see comment, Z equals N, a line showing where the number of protons equal the number of neutrons, my what it means comment would be any point that falls on this line would have an equal number of protons and neutrons. For my what I see comment of Z equals the number of protons, my interpretation or my what it means comment is the number of protons increase as I move up the chart. For my what I see comment of N equals number of neutrons, my what it means comment would be the number of neutrons increase as I move to the right of the chart. For my what I see comment, the plotted points seem to fall below the line Z equals N. My what it means comment would be the larger the atom, the more nucleons, the greater the amount of neutrons. Step 3, caption. Write a caption for the graph or figure. So in this case, we pretty much interpreted the graph to be that the greater the number of nucleons within the atom, the greater the amount of neutrons. If you go back to the video that was embedded in the slides and you watch that video, you'll see that neutrons act as a type of glue that hold together those subatomic particles, in particular the protons, to keep them from pushing each other apart due to the strong nuclear force. So now that you know how to use the identify and interpret strategy, Interpreting this graph becomes quite a bit easier. So what does the n mean? What does the z mean? Use the drawing tool on the graph to the right to identify the line where n equals z. Now think, for atoms that have more nucleons, protons and neutrons, which is larger, n or z? Using your knowledge and the video, explain why you might need more neutrons when there are more protons. We have a short check for understanding. If you'd like to do some reading on identify and interpret, I've included some links at the end of this video. All in all, not too difficult. A rather complex looking chart can become easily understandable if you just take it a step at a time. I hope this was helpful. Thanks for watching.